the high the complete unit is designed a very compact structure. And 4-5 village also we implemented this one. And it is not so complex. One simple inverter and there is a filter circuit and then isolation transformer feeding to the grid. But doing this one, you require a lot of insight into it. Next. So if you go, then this project I did in USA, especially with Professor Ojo in Tennessee Technological University, that they have 12 volt power supply, but you have to make it to 110 volts, and then that power supply need to feed back to the grid. And it was really challenging, and we implemented in Nashville. I will show you 4-5 projects which you will appreciate. One project is in the Port Blair Air Force Station. We installed 1 megawatt solar plant. And I'll tell you what are the challenges when you go to a practical field and implement such big projects. So the proposal is that you need to a bidirectional power flow, then we can completely control this. How my job is I have developed this much. During my research period, it was only 4 months, and that is sanctioned by government. So this I have to design that. So this is a dual bridge converter structure where you are feeding power, then this is like a power system, so I know very well that 2 sources are there, and there is an inductor between that by which you have you can transfer the power from one port to another port. The concept is developed there, and then we fed this power. And then this is called the dual bridge converter. I am not going all the equations, mathematics. You can look into that one. And if you see the power flow from input port to output port can be done just by developing a phase lagging between the bridges. This is so simple way that one phase, one bridge and second bridge, just you change the phase difference, automatically power transfer will change. This is what today V to G and G to V, grid to vehicle and vehicle to grid technology is coming up with this concept of vision. Then next. Then there are also, these are the, these are few results and next. So these few results are what I want to show you. There is no reverse power flow. Generally, reverse power flow is one of the big concepts in a power electronic system as well as the power system also. This next. So if you see, there are a lot of next page. So if you see this one, these converters are being designed and modeled, and then then when we model, there are a lot of limitations in the mathematics, and those assumptions are being conducted. Next page. So if we see this one, you can see that these coefficients are measured and properly put into the circuit, which is very important thing. Then next. Next. Then we want to do a closed loop control. Closed loop control means you want to control very high performance control, exactly whatever your requirement according to you require in the grid, you require 230 volt and you require 50 hertz. These are the characteristics of this. Next. Next. So we developed a 3 kilowatt. Go to diagram. So there are a lot of analysis and control design. I am not going in detail of this one. How to stabilize the system, everything is there. And according to your border plot, phase margin and gain margin, we develop this one. Then next. And this is implemented. So these are the few results. You can see that when you want to transfer the power, for example, 2 kilowatt power is there, and suddenly your solar power increases to 4 kilowatt. So how to do that one? And that type of the large operation is very important thing. So like that, we can feed this power to the grid. So this way you can see that this is zero tracking error we can get by this way. There are a lot of this is the solar microgrid. You want to take power from the solar and feed into grid, and that way you can take power from the grid to the battery, and the battery to grid is possible with this. Next. So there are a lot of the results showing that you can easily transfer this power from grid to the vehicle, and vehicle to grid. So these are the few results that we will go to experiment. Yes. So when you see a simple microgrid, you see you have a solar system, and there is a DC-DC converter which is connecting to the main bus, and also there is a battery, and whenever the battery is not charged fully, you have to take power from the grid. And also you have a lot of this is mainly a ship power system where you can drive a big electric motors as well. So this complete unit we simulated, and complete unit is also implemented in an experimental. This is mainly the switchboard power supply. Next. So these are the few results. You can see that when power is feeding to the grid, it is always remain both current and voltage in the phase. Better you are taking from the grid to vehicle or vehicle to grid. Always it maintain unity power factor. Unity means always maximum power transfer is achieved in this. So this is your experiment where you can see that complete theory is implemented here, and this implementation is carried out. These are the few experimental results. You can go. These are the few experimental results, and if you want to know more about this, you can see that this paper you can read. These are the recent IIT conditions. So you can read that. Then we have a single stage grid integrated system, and you go. So next. So you can see here we have a PV system and a single phase, because in India everybody has a UPS in their house. They can replace that UPS with a solar system. And this integration is very easily you can take this. That is what is low cost system we develop. And it's cost, now you will purchase it in just 6,000 rupees, which we developed and given to one of the companies who is marketing all this. So anyway,
সেই দিলেন বলতে পড়ে এলাম
this is a three-phase system for high power grid integration. It is possible. So most important thing that when you go and in the practical scenario, when you go there and try to implement, there is lot of problems start first in the future design. Exactly those who are doing the solar or wind grid integration, there are three frequencies that need to be taken care. One is frequency, one is